Hello everyone, myself Sneha Murthian from my SA branch. Today I am going to tell a topic about the brute force approaches and dynamic programming. Here the subject code is BCS401 and the topic is brute force approaches and dynamic programming. The first is introduction to brute force and dynamic programming. Brute force approaches involve the solving problems by systematically exploring all possible solutions. Dynamic programming optimizes the problem-solving process by breaking it down into simpler subproblems. Both techniques have their unique advantages and are applicable to various types of algorithm. This is all about the introduction to the brute force and dynamic programming. The next is what is brute force. Brute force is a straightforward method that tries every possible configuration to find a solution. This approach guarantees finding the optimal solution, but often at the cost of high computational time. It is commonly used in problems like combinatorial optimization and cryptography. This is all about the brute force, and this is the diagram how we represent the brute force. Next is the characteristics of brute force approaches. Brute force methods are easy to implement and understand, making them suitable for beginners. They can be inefficient for larger database, often leading to exponential time complexity. Despite their inefficiency, brute force algorithms can serve as baseline for comparing other techniques. This is an example for the brute force. Here the given the branches of A, B, C, and this is an example for the brute force branching. Next is examples of brute force. A typical example of a brute force algorithm is the traversing salesman's problem, that is of TSP. In ADA, one might implement a recursive function that explores all permutations of the cities to find the shortest path. Although simple, this method becomes impractical for a larger number of cities due to the factorial growth in complexity. Here is an example. We can say the brute force algorithm is actually the most straightforward approach to solve a problem. This technique usually involves the direct computation based on the problem statements and the definition of the concepts which is involved in brute force algorithm. This is a simple example of a brute force approaches. Next is dynamic programming. The dynamic programming is a method for solving the complex problem by breaking them down into simple overlapping subproblems. It utilizes the memoization or tabulation to store the result of subproblems, thus avoiding redundant computations. This approach significantly reduces the time complexity for many algorithms, making it suitable for large datasets. This is how to solve the dynamic problems. First, we have to recognize the dynamic problem and identify the various problems, express the recurrence relation, and identify the base case, decide the iterative or the recursive approaches to solve the problem, and we have to lastly add the memoization. This is all about the introduction to the dynamic programming. It will solve the complex problem by breaking them down into the simpler overlapping subproblems. Next is the characteristics of dynamic programming. Dynamic programming is particularly effective for optimization problems and those with optimal substructures properties. It can transform exponential time algorithms into polynomial time, improving efficiency dramatically. Understanding the structures of the problem is crucial for correctly applying dynamic techniques. Dynamic program which is particularly effective for optimization problems and those with optimal substructure properties. So these are the three characteristics of dynamic programming, and this is the same how we have to solve the dynamic problems. First we have to recognize the dynamic programming and identify the problem variables. Next we have to express the recurrence relation and identify the base case. decide the iterative or recursive approaches to solve the problem, and lastly we have to add memoization. Next is examples of dynamic programming. A classic example of the dynamic program is the Fibonacci sequence, where each number is the sum of the two preceding ones. If we take an example of the Fibonacci sequence, we have to take each number is the sum of the two preceding ones. And the next, one can use an array to store the previously calculated Fibonacci numbers, thus minimizing redundant calculations. We can use the previously used numbers to calculate the Fibonacci numbers that minimizes the redundant calculations. This method drastically reduces the time complexity from exponential to linear, demonstrating the power of the dynamic programming. It will reduces the complexity from exponential to the linear form. Here we can see the solve the coding challenges that they have given the examples of the dynamic programming in solve coding challenges. Next is when to use the brute force versus dynamic programming. They have given the differences between the brute force and the dynamic programming. First is brute force is suitable for the for small problem sizes where all potential solutions can be feasibly explored. Dynamic programming is preferable for the larger problems with overlapping subproblems and optimal substructures. Choosing between the two methods depends on the problem characteristics and specific constraints such as time and space. So this is the differences between the brute force and the dynamic programming. In brute force, it is only used to solve the small problem sizes where all the potential solutions can be feasibly explored. Whereas in dynamic programming, we have to prefer the large problems with overlapping subproblems. This is the difference between brute force and the dynamic programming. Next is limitations of brute force and dynamic programming. Brute force approaches can become impractical as problem size increases, leading to excessive computation time. Dynamic programming requires understanding of the problem structure and may involve complex implementations. Both methods may face memory limitations, especially when storing large datasets or results in dynamic. Next, the final conclusion. Both brute force approach and the dynamic programming are essential tools in algorithm design. Each method each method has its strengths and weaknesses, making them suitable for the different types of problems. Understanding when to apply each technique can significantly enhance the problem-solving efficiency in analysis and design of algorithms. Thank you.